Okay, let's look at the practice exam 1, problem number 2. Right. So first, we have two functions given, and we want to find the composition g of f. All right. So let's do that. All right. So g of f of x, right, is g is the outside function, f is the inside function. Right. So let's replace f of x by the definition here. So you have a g of, right, f of x is x plus 1 over x, right? All right, then we have to look at the definition of g. Every time we see x, we're going to put x plus 1 over x in it. So this is going to be, right, I see x here, so I'm going to put x plus 1 over x, and then plus 8, and all over, and I see x there, so we put the x plus 1 over x there, and plus 2. Right? So since I don't like to have fractions inside fraction, so I'm going to just multiply top and bottom by x. Right? Just to make it look prettier. Alright, so x times x gives you x squared. X times 1 over x, that gives you 1. And x times 8, so you get 8x. And on the bottom, x times x gives you x squared. X times 1 over x gives you just 1. And x times 2 gives you 2x. Right? You can actually, on the bottom is x squared plus 2x plus 1, so you can actually complete the square there. It's really the same thing as x plus 1 squared. And on top, I don't think we can do too much, so I'll just leave it as it is. Right? So this is the g of f of x. Right? So we got the formula. And then we have to find its domain, right? So first, we have to make sure that there are two things we have to make sure. One, you have to make sure that the x is in the domain of f, right? Look at the domain of f, right? So because there's an x on the denominator, so we cannot have x cannot be 0, right? So since domain x has to be in, so x must be in the domain of the inside function, in this case f, so domain of f, right? Which is x cannot be equal to 0, right? So which means that we have to avoid 0 there, right? And 2, since you are plugging f of x into a g function, so we have to make sure that the f of x is in the domain of g. So number 2, so f of x must be in the domain of g, right? Which is, right, so -2, we have to avoid -2. So all real numbers except -2, right? All right, so we have to avoid that f of x. So f of x is this guy, so x plus 1 over x. And we cannot have this equaling -2, right? So I don't like fractions, so let's try to solve by multiply both sides by x, so that we have x squared plus 1 over x times x is 1, and it cannot be equal to, and -2 times x, -2x. All right, then I'm gonna add 2x to both sides, so that we have x squared plus 2x plus 1, right? Which is just x plus 1 squared, which we did here. So we cannot have a equaling 0 because we move this guy over to the other side. So you have 0 on the other side. All right, so which means that let's see, only other bad number would be x equals -1, which makes it 0. So x cannot be equal to -1. All right, so we have to satisfy part 1 and part 2 at the same time. Part 1 said that the x cannot be 0. Right? Part 2 said that the x cannot be -1. So domain would be all real numbers except for 0 and the -1, right? So therefore, domain of g of f is equal to -infinity to -1, and then skip -1, go all the way to 0, and skip 0, then go all the way to positive infinity, right? So that is the domain of the composite function g of f. All right, that's it. I hope that this was clear.